Okay, welcome back. Now I'm going to do a demo. I'm calling this lenses. I'm going to be talking about the curvature of lenses and the kind of images that they produce and their relationship to the issue of nearsightedness and farsightedness. What causes some people to see near better instead of being able to see far? Those we call nearsighted. And farsightedness is basically the people who could see far that can't see near. Usually farsightedness occurs as you age, when you get older, but nearsightedness usually occurs in the younger. So I'll explain what the differences is. We're going to have here 4 converging lenses. Converging lenses I've talked about before. They are the ones that are fatter in the middle. So they're numbered 1, 2. You can see here, number 1, it's the most curved. We say this lens has the smallest focal point, the smallest focal length. So its focal length is going to be closer to it, and it's going to be a stronger lens. The smaller the focal length of a lens, the stronger the lens is. That means it can take direct light rays, bend them all the way to the focal point. Then if the curvature is strong, then the focal point is small, and it can quickly bend those light rays. Number 2 is this one. It's not as curved. And then you got number 3. It's more gently curved here, so it's weaker. And then 4 almost has no curvature. So if we put this on now, number 1. Okay, so we could put a dot here and label that the focal point of number 1. So let's draw the outline like this, like this, like this. So I want to put them around the same location. Okay, now let's take that one out. Let's put number 2. Actually, you can see the focal point of number 2 is actually smaller, right? So upon closer investigation into the curvature, I can actually tell that I was wrong. The curvature of 2 was stronger. It wasn't in the same order. You see, number 2 curved like this, way curved. And number 1 was a little bit flatter, and it was wider on the bottom and the top, right? So the 2's curvature was more. That means it is a stronger lens. Okay? So its focal point is somewhere here. Okay, how about number 3? Number 3 is going to be here. So the 3 is weaker than 1. Okay? So it went like 1 was in the middle, 2 was the strongest, 3 is the weakest of the so far. And then you just put it, it's way over there. It's so dim that you can't even see it. Okay? So it's pretty much, it's going to be so weak that the focal point is somewhere there, all the way here, number 4. Okay? So we can tell from this, 2 is the strongest. Then the next one is 1. I'll put them in order here. Then it's 3. Then it's 4. We can do the same thing for diverging lenses now. I've got diverging lens number 5. So now I turned off the light and I'm going to put number 1 again. Number 1, you can see is here. And then if we put number 2, and if we put number 2, you can see the focal point is closer, right, to the lens itself. The distance is a lot closer. So this is the strongest lens. And then this one is number 3. It's the one farthest out, right? And then number 4, it's so far out that it gets so dim, basically. You can, it goes all the way to the end of the board and you can't even see them. Okay, so now, this is the diverging lens number 5. See how the diverging lens make the light rays bend outward? So then, if I want to know its focal point, you look here, and then you see how the lines are going here. They never converge here, but where does it look like the lines are coming from. So you have to look here, kind of trace out, trace this backwards. Right? So because the light rays are bending out, you go backwards and see where they're coming from. And when you do that, so you see the light rays were bending outward. When you go back, you see the focal point was here. Right? So this is number 5. Okay, so this one you can tell the light rays are bending outward like this. Then you go back. Actually, it ended up being stronger because the curvature of that side, even though one side wasn't curved, but the curvature of the other side was stronger than this one. Number 5 had two sides curved, but it was a gentle curve. The one that I used was one side planar, the other one curved, but its curvature was stronger, was more curved, so it ended up being a little closer point. So we would say this one, the focal point is closer, and it's a stronger diverging lens than the other one. So now let's relate this to the issue of nearsightedness and farsightedness. Okay, so I'm going to put this board here. Okay, so a normal person that does not have nearsightedness or farsightedness, their eyesight is going to be such that it will be equivalent to using converging lens number 1. Remember, number 1 was not the strongest, 2 was the strongest. So that would be the regular, we can call that the normal person with good vision. I'm going to put that over here. Okay? And when the light rays are coming, the focus should be in the back of the eye in the retina. So the light rays come nicely and converge. And if I follow them, let's see where they meet, right? See that their focal point is such that they form an image in the back of your eye, in the retina, right? And then your brain can interpret that image as a good, sharp image. So that's a normal person with a normal eyesight, a 20/20 vision, right? What happens when a person is nearsighted? When the person is nearsighted, it would be like you're using lens number 2. The lens is too curved on the edges and it's too strong. Its focal point is small, that means it's a strong lens. So when you're actually nearsighted, that doesn't mean your eye is weak, it means your eye is too strong. That's kind of a weird thing, right? We would think that the nearsighted person has weak eyes, they're too strong. So now let's put number 2, right? I'm going to erase the original one, this one. That's your eye is too strong and it forms an image earlier than it's supposed to. It forms an image here. So that's too strong. So how can we correct your vision now? Well, you could have Lasik surgery, which means to shave off the curvature here, right? Shave off the curvature. I've had that about 6-7 years ago, where they shaved off the curvature of my eye. I was able to see. I was very, very strongly nearsighted. This person can only see objects that are near, because objects that are far, the light rays are going to be coming straight and they're going to focus too early, right? So they can only see near. So how can we correct it? Well, shave it off, have Lasik surgery, or put a diverging lens. You want to wear glasses that have negative focal point. They are diverging lenses. Lens number 5, and see if that will correct it. So what's going to happen? Wearing a diverging lens for these people, since their eye is too strong, too curvy, right? They're forming an image too early. So we want to fight against the curvature of your eye by wearing a diverging lens. So objects that are near, the light rays are going to come like this, right? And then the diverging lens is going to diverge them outward, like that. So they're the diverging lens is fighting against the strong converging lens that is your eye, right? Your eye is too curvy and too strong. So then what's going to happen? This will enable now the light rays to form behind where they were, because it was too fuzzy. And now the light rays are going to form and converge at the retina of your eye, and you should give you a good image. So I'm going to use diverging lens number 5. If that doesn't help, I'm going to use the other one that was stronger. This one is bending it in, it's now bending farther out. I think this did the job already. The image was formed in the retina. Instead of this first original red light, then now it's the black one, so it did the job, it fought against you. So the more curved your eye is, that means the stronger, the more curvy this one has to be, which means your focal point is going to be closer and closer and closer to this lens. It's going to be a stronger lens, right? And it's going to be negative. So when I was wearing contact lenses, my prescription was -7, -8. Some people were -10, -20, right? Or you could get the Lasik surgery and then they shave that off. The other thing they can do now is they can open the flap of your eye and insert this diverging lens into your eye, right? And you don't need to actually shave off the eye, okay? Now what happens when a person is farsighted? Okay, if a person is farsighted, that usually happens through age, right? And what that means is their eye is too flat, right? And it's not strong enough. They've lost the flexibility over the years. They've lost the flexibility to make it fatter in the middle, right? So it would be the equivalent of having number 3 or number 4, right? Number 3 or 4. If they're really, really weak, it would be 4, because remember 4 was almost flat. Let's use number 3 so it's not that severe. So what's going to happen when I put number 3? Okay. Remember 3 was the weaker from the 1 and 2. It was weaker, but it wasn't as weak as number 4. So the light rays are coming and forming back here. This is the focal point. Okay, so you can see here the light rays were forming a sharp image behind the retina. Well, that means when they hit the retina, they haven't actually come and made a sharp image yet. So the images are all going to be fuzzy. So how do we help this individual? Since their eye is not too curvy, right? This one is a harder, trickier to do Lasik surgery because it's not too curvy. So how can you shave this off? It's going to make it worse. You're going to have to shave off the ends, right? So the lens looks like this. It could be done, but it's a trickier surgery. Since the lens is like this, it's not too fat in the center. This was lens number 3. So how do we make this curvy? You can shave off the ends like this. You see? Shave off the ends, not the middle, right? So to make it more curvy. So it's a trickier Lasik surgery that could be done. Or if you want, you can open the flap, the cornea of your eye, put another lens similar to it, okay? So if you're not going to have Lasik surgery, how do you correct it? Well, you wear glasses that have the same kind of curvature that aid your eye. So you have the glasses with positive focal point, right? So nearsighted people wear negative diverging lenses, negative focal point, and then farsighted people wear positive focal point. And then their glasses are also fatter in the middle, whereas the nearsighted people, their glasses are thinner in the middle, right? So which one should we do? Probably I'll use number 4, right? Because if I use number 1 was on the regular eye. That's too strong for this person. So if your eye's weakness is 3, I'll use the number 4, which was a gentle curvature. If your eye's weakness is a 4, which is you're really weak, then 3 will help you. So 3 can help the 4 if your eye is a 4. If your eye is a 3, then the 4 can help the 3. So let's do this here. Turn off the light. Okay, so this is actually working because it brought the image closer and it's going to form in the retina. I'm going to draw those lines, right? Or I can switch them. I could put, let's say your eye was really weak and you were really old, really weak. So then I could put number 4 as your eye and then you would wear a number 3. Well, the combined image is the same. It doesn't matter if the order of the 3 and the 4, right? So then we can turn on the lights. and then see where the image was. You can tell here when I trace back the lines, the image is where your retina is, right? So now you can see a little bit about the difference between nearsightedness and farsightedness, how we can correct them, and why the nearsighted people we need a diverging lens, and why the farsighted people we need a converging lens. So you can see the difference between the two, and then see also the difference between the curvature of the lens and the strength of the lens, okay? Thank you very much.